All right, this is just a review. So going forward, starting off at the header inclusions, we're going to be reviewing the different components of our Hangman game as it relates to the overall course objectives. So the IO stream facilitates input and output operations using the CN and cout operates and others. We have our string, which provides the string class for handling text. Vector offers the standard vector container for dynamic arrays. And ctime grants access to time related functions such as time itself, used for seeding the random number generator. We have cstdlib, which includes functions like rand and srand for random number generation. We have our algorithm, which supplies algorithms like standard find, used to search within containers. Our game state structure encapsulates all the variables pertinent to the game's current state. We have a few members, such as secret word, which is the word that the player is trying to get. We have display word, which is the current state of the word, revealing guessed letters and hiding others with underscores. For guessed letters, it's a list of letters that the player has already guessed. And remaining tries is the number of incorrect guesses the player can make before losing. And then is game over is a flag indicating whether the game has concluded. Now we got to select a random word. So the function here randomly selects a word from the provided word list. And it uses srand time null pointer, which seeds the random number generator with the current time to ensure varied outcomes. So your rand modulus wordless size generates a random index within the bounds of the word list and returns the word at the randomly chosen index. Then we initialize the game, which sets up the initial state of the game. Dynamically allocates memory for the new game state object, assigns a randomly selected word to the secret word, and initializes the display word with underscores corresponding to the length of the secret word, and then sets remaining tries to the specified max tries, and marks is game over as false. Then we can display the current game state, which outputs the current state of the game to the console and displays the display word, showing guessed letters and underscores, and lists the letters the player has already guessed and shows the number of remaining incorrect guesses allowed. We've got to process the guesses that the player makes now. So this function handles the logic when the player makes a guess, checks if the guessed letter has already been attempted, adds the new guess to the guessed letters, and iterates through the secret word to reveal any occurrences of the guessed letter in display word, and then de-increments remaining tries if the guess is incorrect and determines if the player has won or lost, which updates the is game over accordingly. Last but not least, we have our main function for the game execution. It orchestrates the game's flow and defines the maximum number of allowed incorrect guesses, initializes the game state with a list of possible words, and welcomes the player. It enters a loop that continues until the game concludes and displays the current hangman stage and game state. It prompts the player for the letters to guess and validates the input to ensure it's an alphabet character, and then processes the guess. Upon the game conclusion, it'll deallocate the dynamically allocated memory.